Hello again. We're back. Okay, what I want to do right now is to finish up on chapter 4, and do have some miscellaneous things I want to go over with you. Okay, so let's take a look on that last page of the questions, which is page, let's see, page 100. Okay, question number 9. Compute the volume of a rectangular tank that measures 8 feet by 4 feet by 10 feet. Okay, this one here is just straight math. So this is length times width times height. Okay, that's how you would write it. Sometimes you'll see it written like that, cubic contents. Okay, in this case here, they just give you measurements in feet, so that's going to work out to cubic feet. All right, it's three-dimensional. So it's 8 by 4 by 10. Okay, this one you could actually do in your head. 8 times 4, 32 times 10, 320. Okay, so this equals 320 cubic feet. Okay, now I know the other night I mentioned it, but I'll mention it again. Very much like working out how much air you need for a boiler. Now, some of this, like this cubic contents, is pretty vague. I don't know. Other than for the boiler, I don't know where you're going to use this one. Even for liquid, we don't usually get involved in it. But you could. I guess you could. All right, so here we go. 320 cubic feet. That would be the answer for number 10. No, excuse me, number 9. Now, what they did for number 10 is they took number 9 and they asked you to convert it to gallons. Okay, and then they ask you to change the depth. All right, so let's do it for the whole. They didn't ask this, but I'm going to do it first. All right, so let's say that we had 320. This is not number 10. I'm just going to show you how you would do it. 320 cubic feet. Now, we've done this before, earlier in the year, maybe October, November, we did formulas. And if you remember, to convert cubic feet to gallons, you multiply by 7.5. Remember that, 1 gallon, 1 cubic foot. Equals 7.5 gallons. So if you take a cubic foot and you had a 1 gallon pail, it would take 7.5 to fill it up. So if you multiply this here, let's see what we got. We got 320 times 7.5 equals 2,400. Okay? 2,400 gallons. All right. That's the kind of problem number 10 is, except they changed the numbers around a bit. So I'm going to do it down here. But if they asked you to take this and make it to gallons, that would be the answer. All right, I'm going to get rid of this. And let's do number 10. Okay, so number 10 is 8 by 4. And this is where they get a little tricky here. Um, I'm sorry, I can't see that. I think it's 6 feet. All right, if that is 6 feet, it look like this here. All right, so you got 32 times 4 times 6, and let's see what we got. 32 times 6 equals 192 cubic feet. Okay. Now, if they were looking for, oh, I see. They're asking if the same tank, but it's not full. It's six. It's filled to 6 feet, so there's 4 feet at the top. All right. Now, what they didn't ask, and I'm going to tell you about because I've seen this before pop up on tests. Let's say that they said how much water would be in this same tank if it only had 6 inches of water. Now, sometimes they'll mention a roof. They'll give you the size of the roof and say it's 3 inches deep. How much water? All right. So let's say that this one was 8 by 4. All right. I'm going to change it. Take number 9 away. I'm just going to use the numbers. 6 inches deep. Okay, don't panic. This is very, very easy. So what we got is 8 times 4 is 32 times 6 inches. 6 inches is half a foot, right? Or 0.5. So what is that? Half of 32 equals what? 16 cubic feet. Okay? And 16 cubic feet would be not that much water because it's only 6 inches deep. All right? Pretty small. But 8 by 4 is also not a very big big area. That's a sheet of plywood. So if you got water 6 inches deep and it was just on like something the size of a sheet of plywood, it's pretty heavy. It's going to be cubic feet, 62.5 per cubic foot. You got a lot of weight there, but that's not what we're looking for in this problem. The answer we're looking for today is cubic feet or cubic contents. All right. So don't let the inches fool you. Real quick conversion. I want to write this down because I haven't talked about it, nor is it going to be coming up. 6 inches equals 1/2 equals 0.5. Okay, this is the one you want because you can do on a calculator. Not so much over here. Let's see. 3 inches equals 1/4 equals 0.25, right? 9 inches equals 3/4 equals 0.75. Now, of course, you can throw in 3/8, 5/8, 7/8, and so on. Some of them you might know. I don't know all of them. The conversion. 1/8 would be what, half of this, 12.125. But these here give you an idea how to do it. All right, using a calculator. There it is, right there. Right, 6 inches. Right, half a foot. Okay, everybody got that? Okay. All right. Let's see what else we got here. Okay, they get into cylindrical tanks. Hold off on that. That's a whole nother thing. So skip that one. Cylindrical tank. I'm going to do that one, but we'll do that one last. If the sewer line shown in figure 4.25 is laid using 10-foot lengths of pipe, what is the total slope per length of pipe? And they just told you it's 10 feet. So what I'd like you to do is to flip back to page, hold on a second, 97, top of the page. I know your page is on in a book, but I think that you can see the number. All right, it looks like a transit shooting a line, straight line, and then you got the pitch. Inlet, outlet. All right, and what they have is a 50-foot run of pipe. And the total pitch for the pipe is 50 feet. For 50 feet of pipe is 6¼ inches. All right, so what they're looking for is a 10-foot length of pipe. So how are we going to do that? Okay, let's take a look at number 12. And what you have is 50 feet, right? And you have a 10-foot length, right? 10 feet equals how much? 50 feet equals 6¼ right? Total pitch. Now let's see. It's 5 of these here, right? It's 5. So let's divide 5 into 6 point. Here's where the conversion is handy. 25, right? 1. All right, let's do it out the long way. 12, 10, 5. Everybody see that? 1.25. Okay, what's that? Inches, right? Excuse me. Yeah, 1¼ inches, right? So 1.25 equals 1¼ inches per 10-foot length of pipe. Okay, that's all they asked for. Okay, that was number 12. Number 13. Now this one here, I have never seen this on a test, nor have I heard that they've asked for it. And the book even mentions that plumbing has avoided the metric measurement more than other trades. They even mention it in this book, and we all know that. All right, we've been lucky. Occasionally, and they mention it here too, occasionally you get some, maybe from Germany or somewhere overseas, where it comes in metric size, and it's a pain in the butt. But for the most part, they stay clear of it, as do we. And I did mention, I think last class, that, at least my understanding, they were using millimeter to measure weapons back in the 40s, and I suspect it goes back far before that. But overall, we've managed to stay out of this. The only ones I know that really get hit are the mechanics, because a lot of their stuff is metric. A lot of the cars are metric, and so they got to keep two of everything. And those of you who you all work with tools, so you'll know the answer. But you notice that metric and we call it SAE are standard sizes. They don't match up at all, right? If you don't have two sets, you're gonna have to use an adjustable wrench because it just doesn't work. Okay, so is a meter longer or shorter than a yard? Okay, that's number 13. Okay, a meter is longer, and I think most of you know that. A meter is a little bit longer. It's almost 10% longer. If any of you guys ran track in high school, I know my time, the 100-yard dash was 100 yards. Now I believe they've switched over to 100 meter. I know at the Olympics they have. And these guys are unbelievably fast. They're running like, I remember, very good time, it was only high school, would be like 10 flat for 100 yards. These guys are running under 10 seconds for 100 meters. That's like 110 yards. That is 110 yards, almost exactly. All right, but the answer they're looking for is that a meter is longer than a yard. Now, there is a conversion, and it's not a complete conversion because I was looking for it, and it's not there. Convert feet to meters, multiply, where is it here? Feet to meters, multiply feet by 0.3048. Okay, so if you want to convert feet to meters, multiply 0.3048. Okay, I know how much use that is. But I looked it up, and 1 meter, if anybody wants to write down some trivia, is 39.37 inches. It's not a number I remember. I had to actually Google it. But the formula for that is 1.09 times the feet will give you the meters. All right, so it's almost 10%, right? Not quite 10% more. And actually, I just fooling around. I took 100 yards to 100 meters, 300 feet times 1.0936. That's the conversion. It comes up to 328 feet, which is almost exactly 10% more. Now, another thing. Let's finish up these questions here. All right, number 15. That was number 14. Excuse me. Number 14. A cubic inch larger or smaller than a cubic centimeter? All right. What they tell you is that 1 inch is a centimeter times 2.54. So a centimeter is considerably smaller than a cubic inch. All right. So the answer is 1 inch is larger than a cubic centimeter. They mentioned the conversion on the previous page. All right. That was number 14. Number 15. Is a quart smaller or larger than a liter? Now, I think you all know that a quart is smaller than a liter, and I didn't really get into it much here. I honestly don't remember that one on a plumbing test or hearing about it. That would be on the previous page. They mentioned that a quart is 0.946 of a liter. So that would be about 5% more. So a liter would be about a 5% extra. Now, if you ever bought a giant imperial quart, I remember when I was a kid, and you buy beer, not kid, excuse me, when I was older, it was a giant imperial quart, and it was, instead of 32 ounces, it might have been like 36, 37 ounces, a little bit bigger than a quart. Okay, but the answer to the question that they asked is a quart smaller or larger than a liter? The answer is smaller. Okay, number 16. A meter is how much larger than a centimeter? I don't know that they actually said so in the book, but I think all of you can answer that. Centimeter is 1/100th of a meter, right? So a meter is 100 times larger than a centimeter. Now a centimeter is 100 times bigger than a millimeter. Millimeter. And I think I mentioned to you in the last class, 105 millimeter, which we used to use on tanks, which I don't know if they still have that in the inventory, but they used it. Actually, it goes back to World War II. A gun that size, a 105 millimeter, is actually 4 inches and change, which would translate into that. The conversion all makes sense. So a meter is 100 times bigger than a centimeter, and a centimeter is 100 times bigger than a millimeter. Okay. Now, what I'd like you to do is to go back to number 11. That's 11? No, the one I asked you to skip. Cylinder. Yeah, number 11. Okay. And what they give you is, I don't know. I honestly didn't even look at their formulas. Our formulas on the formula sheet I gave you at the beginning of the year, there are some formulas on it. And if you have that sheet, or that, if you could download it right now, let's take a look. I'm going to write it down. I'm going to spend a minute on it. Let me double check the time, see how much time we got. 4:06. Yeah, we got a bit of time. Now, if you're looking for gallons in a cylinder, this one was popular at least 45 years ago when I was in night school. And I checked with one of the guys in night school. I'm not sure if it was Henry or who it was. Somebody who was more up to date on what the state has been doing for formulas. And as far as they knew, the question is still part of the curriculum, right, or part of their pool of questions. Because I've heard that they have, we'll say, 1,000 questions, and for an exam, they'll randomly take so many out from each category. I don't know exactly how they do it, but this is still part of it. So, and this formula is not one that'll be given to you. If it's something off a chart, gas pipe sizing, things like that, they'll give you the chart. Water pipe sizing, things you will get the chart. You just gotta know how to use it. This you gotta know. So there's 3 formulas that I suggest you memorize. I'll write them down here, but if you got your formula sheet, take it out. This is gallons equals diameter, square, and inches. Okay, that's the first one. Notice inches and inches. Okay? The second one. Okay, this one here is if the diameter is given in inches, but the height or the length is given in feet. Then you use this formula. All right, and the last one is diameter square in feet times the height in feet. Okay? So the formulas, the problems that you get should fall within one of these 3. You got to pay attention right here because the formula different is the constant over here. It changes. All right, so the problem they gave us, or gave you, was if you have a tank that's 8 inches in diameter and it is 20 inches tall. All right, they stand it up for us. But always, even if it's a horizontal, the just picture the tank standing on end, right? Because usually it's given, call it the height. All right, so what we have to do now is decide what formula we're going to use. So let's see what they gave us. Gallons equals the diameter squared, and what is it, feet? Yep, it's given in feet, times the height in feet. Okay, they're both in feet. Fine, that's okay. That means this one. All right, so what do we got? Equals 11, 8 and 20. Okay, what I'm going to do is go right to the calculator here just to save time. And let's see, 8 times 20 equals 7,020, 7,520 gallons. There it is. Now, I don't know if I believe this answer is correct, but there is a way you can use this to go back and check it. And no, I didn't check it here. I don't see it. So this could work out, and maybe it won't. We'll see. Let's see what happens. Okay, if I want to check my answer, what I can do is change this 8 to inches, right? So it'll change the formula, inches and feet. It'll be this one. So I'm going to take this and convert it back to inches, which will be right here. So it'll look like this. All right, so we have the diameter is going to be, what, 8 times 12 is 96 square times h is 20 times, now we go back to this formula here, right? All right, I'm going to go right to the calculator, and I hope this works out, because I did not double check this one. So we got 90. Oops. 96 times 96. There it is, 7520. See that? It actually worked. Okay. Okay, so what I did to double check, these you should memorize. I know it's a pain in the butt, no doubt about it, but memorize these. And if you do, then you can take a problem like the one the book gave us. And then what I did is I just changed the feet that they gave us, and I went to inches, right? So I changed this, right, to 96, which made it inches. So I went from this formula to this one, and the constant made the allowance, right? And there it is. I got the exact same answer, which proves that this is correct, right? So if you have time on the exam, usually you don't, but if you do have time and you want to go back and check your answers, you never double, what do you call that? Don't try to, sometimes you kind of outthink yourself. Don't do that. But if you have a chance to prove it and you know how to do it like this, it's worth it, right? You can see if you made an error. If your answers aren't matching up, find out what you did wrong. Okay, so this here is a big deal. I definitely want you to remember this. It's on your formula sheet. And I'm going to put some questions down I'd like you to do for next week. It'll be your assignment. All right. See how we're doing for time. Got a little time, not much. Now, actually, there's a few problems that come up with these. The next page, page 101, there's a few questions over there. And the last two actually are what I'm going to show you right now. So let's get rid of this. Now, I forgot to, last week I mentioned that length times width times height gives you the volume like for a basement. Remember that? And I said that we use that all the time when we size them up for boiler. You should be anyway. Now, what your boss does, that's his business. Just pay attention to what he does and whether it's good or bad. Usually you can find a lot of good things your boss does, and none of us are perfect, and you can also find things you could improve on. But if you're doing a boiler, and especially if you pulled a permit, like you should, because you got water coming in, you got smoke pipe going out, you definitely want a permit. So if an inspector shows up, and you have a cellar that's clearly too small, he might call you on it. I think I told you when I had a electrical inspector over to look at some wiring, it had nothing to do with the boiler. He just walked by the room and the door was open to the boiler, and he said you should have a fan in the can. I think I told you that. Well, that's the electrical inspector. What's that? and I know the guy. I mean, I know the guy pretty well, not real well, but pretty well. And he was just doing me a favor to tell me that we should have a fan in the can, and he was right. And I actually had the fan in the can. I hadn't hooked it up yet because we had closed that room off. But even with just the cellar wide open, the only house that I find that can usually give you enough air is a ranch house because the basement is big because you only got one floor. You got a cape, you got a smaller, it's not as long, and the basement is slightly, quite a bit smaller. You might have some trouble meeting the air requirements. Okay, but remember, if you didn't write this down before, write it down now. So if you want to know if you're doing a job, even if you're putting one in on the side on your own, um, if it looks like it's too small, small in area, trust me, it's too small. If it even looks close, it's definitely too small. What the formula you want to use is, let's say you did a basement and the ceiling was 9 feet and the cellar measured, let's do 25 by 40 by 9 foot. I think we used this number recently too. 25 times 40 is, what's that, 1,000? I think that's 9,000. All right. Even if it's wrong, don't worry about it. Okay, so this is how much air you've got. Now you got a boiler. 135 input. That's what it takes for combustion, right? Doesn't matter what the output is. That's only valuable for your baseboard or your radiant. 135,000 boiler times 20. Oh, excuse me. 135,000 BTUs input. And so you need air for that. Now you take this and multiply it by 20. Okay. This size basement, which is big, that 40 is big. That's getting up around, that's ranch house size. 25 front to back, it's about right. 9-foot ceiling, I'm being a little generous. It's usually closer to 8. All right. But you throw in a water heater, a 60,000, you make it a 50. So you got 135 plus 50, right? Now what? 185,000, right? Now, most guys aren't going to bother. Close enough. Nobody's going to get too excited. These two, yeah, they'll be on occasionally together, the water heater and the boiler, but not that much. But if these numbers weren't close, you really should put in a fan in the can. Okay. Now remember, I went with a big cellar, and that's not a big boiler, about average, I guess. So that's how you do it. The key to remember is length times width times height times 20, right? Equals BTU input, or it should. Okay. The thing you don't want to forget is this right here. Because if you just multiply those three together, you get nothing. 9,000. That's not much, right? So that's how you do it. All right. Let's take a look at, and I don't think I'm going to have time to do it completely, but I'm going to mention it quickly. There's two. Damn. All right. Got to make this very quick. This one here is strictly a test question. It's, those bank signs where it'll say Celsius and it'll say Fahrenheit. If it's there's only one number that I'm aware of where it's Celsius and Fahrenheit are both even numbers. I'm going to show them to you. All right. So I'm going to write this down. These are constants, all right? So let's say that the Celsius is going to be, usually it's less than the Fahrenheit, right? C equals, we're looking for C, right? That's what we're looking for. Let's say the Fahrenheit is 59 degrees minus 32, just a constant, that's all it is, divided by 1.8. So this is going to be 59 minus 32 equals 27, right? Divided by 1.8. If you do the math, okay? Write this down. That's all you need, right? Now, it does get a little tricky when you get below zero. You know, like for one of them, like you got 15 degrees Fahrenheit and you get Celsius, or you get, you know, then it gets a little touchy. But if they're both above zero, you know, both above freezing, they work out just fine. Okay? But these are the only two numbers, 15 and 59. Now, if I do the reverse, let's do that. F equals 1.8 times C. I'm looking for F, right? I don't know the F. But the C was, we'll say 15. I'm sorry. Plus 32. Okay, that's the formula. I'm trying to cut this short. 1.8 times 15, right? Plus 32. F equals 27 plus 32. Here you go. Done. All right, now I'm afraid to take this any longer because I don't know if it's going to record. So what I'll do is I'll give you a few problems. That'll be the last part of tonight's class. I'll give that to you when we go live. All right. Now, obviously, you won't see this until after you see me in class, but the problems that I give you during class will be for this chapter. Okay, also, I didn't mention it. I think I did. Questions 17 to 20 I didn't get to tonight. I'd like you to finish those up. 19 and 20 was like this. So do 17, 18, and 19 and 20. And I will see you, I guess, next week.